All right, welcome back to Asteroids, Comets, and Dwarf Planets, Part 2, Chapter 12. Today I'm going to focus in on Pluto. Is it a dwarf planet? Is it a comet? Is it a terrestrial planet? And then I'm going to talk a little bit about some cosmic collisions, small bodies versus the planets. So Pluto is kind of considered a lone dog. Well, was considered a lone dog because it didn't quite fit with being a terrestrial planet, being that it was in the outer solar system, and there's a few other discrepancies. And so now Pluto, I know we've classified it as a dwarf planet, but it actually has a lot of characteristics of a large comet. So Pluto's orbit will never ever hit Neptune. Notice it's at a slight ellipse, so it's not in the same plane as our other planets in the solar system. Neptune orbits 3 times during the time Pluto just orbits twice, and they do cross paths, but like I just said, they will never hit. So is Pluto a planet? Well, if we take a look at Pluto, it's much smaller than any terrestrial or gas giant Jovian planets. It's not a gas giant. Okay, it's terrestrial, sort of. It's got an icy composition like a comet. It's very elliptical. It's got an inclined orbit. So it actually has more in common with comets than with the 8 other major planets. Pluto does have a moon. Charon is nearly as large as Pluto itself, probably made by some type of major impact in its past. It's very cold. It does have a thin nitrogen atmosphere that can refreeze as it goes further away from the sun, and then when it gets closer, it tends to melt. Okay. There are other icy bodies in this area, just like Pluto, on an elliptical inclined orbit beyond Neptune, and the largest of these, Aries, was discovered in the summer of 2005, and it's even larger than Pluto. So, Kuiper Belt objects tend to be large icy objects. Basically I just want to talk a little bit about large comets versus small comets. But large objects in the Kuiper Belt do have orbits and icy compositions like those of the comets. So there are some other Kuiper Belt objects, but little is known about them. New Horizons has studied Pluto and a few of the other Kuiper Belt objects in a planned flyby. It's already taken place. At least I think it has. Actually, probably should look that one up. I feel like it has. And so hopefully we can decipher that information and learn a little bit more about Kuiper Belt objects. Okay, so basically bottom line, Pluto is almost like a large comet. Okay. Last section is talking about collisions. Okay. Have we ever witnessed, that's supposed to be ever, witnessed a major impact? So back in 1994, a comet actually crashed into Jupiter. And it left like a gaping hole in the atmosphere of Jupiter. And, as it was crashing into Jupiter, the tidal forces of Jupiter also tore it apart. And there's like impact plumes that just showed up on Jupiter's surface, and you can kind of see that here. Here's the damage after. Another unknown object struck Jupiter in July of 2009. It's just like literally a gaping hole in Jupiter's atmosphere. So why is it important to study cosmic collisions? Well, we believe that some mass extinctions in our fossil record might have been caused by a cosmic collision, and the most recent was the dinosaurs 65 million years ago. Evidence for it is a very rare element called iridium. It's very rare on Earth, but it's very common in meteorites. And so the Alvarez, Lewis, and Walter did find a worldwide layer of iridium laid down 65 million years ago, probably by some type of meteorite impact. And all the dinosaur fossils all lie below this area. So here's the iridium layer. There's no dinosaur fossils up here. Here's the iridium layer. All the fossils are down here. So consequences of an impact. First off, if a very large meteorite, maybe 10K, so like that's what, 10, let's see, a 5K is 3.2, so 6 miles across, would send large amounts of debris into the atmosphere. The debris that gets shot up into the atmosphere could reduce sunlight and affect maybe producers. It could result in climatic changes that could have caused the mass extinctions. One of the most likely impact for that meteorite that struck 65 million years ago is the Yucatan Peninsula in Mexico. We have found a very large subsurface crater. Yeah, so you can kind of see this is an artist's rendition of what it possibly could have looked like. But if we zoom in on that Yucatan Peninsula, you can kind of see that we do have rings or concentric circles from some type of collision that occurred previously. Okay. So is the impact threat a real danger, or is it just some media hype? So we know that asteroids and comets have hit Earth. A major impact is only a matter of time. Okay, so it's not if, but more like a when. However, major impacts are rare. They do tend to occur millions of years apart, especially the extinction level that could result from it. Major damage tends to hundreds of years apart. Back in 1908, in Tunguska, Siberia, 40 meteor object in diameter disintegrated and exploded in the atmosphere, leaving damage like this. Actually, if you look this up, there's a lot of conspiracy theories around that one too. It's kind of cool. It shows up in X-Files a lot if you watch X-Files. So the frequency of impacts. Small impacts happen almost daily. So here's a crater made by an impact from just a 1 to 2 meter object. So between 3 to 6 feet. And you can kind of see the crater size from it. Impacts large enough to cause mass extinctions happen, just like I said, millions of years apart. Now I'm going to read to you some information just from a book I was reading. It says, there's little doubt that major impacts have occurred on Earth in the past. Meteor crater in Arizona formed about 50,000 years ago when a metallic asteroid roughly 50 meters across crashed to Earth with an explosive power of a 20 megaton hydrogen bomb. Although the crater is only a bit more than 1 kilometer across, the blast and ejecta probably battered an area covering hundreds of square kilometers. Meteor crater is relatively small and recent. So just to show you that, yeah, when collisions occur, there's a lot of energy associated with it. So the asteroid that has our name on it, we haven't seen it yet. Deflection is more probable with years of advance warning. And I'm sure you have this, I'm supposed to say probable, but, you know, maybe we could shoot it up and break it into smaller pieces, or, you know, find a way to deflect it, or send a probe and, you know, with boosters, or maybe you've seen the movie Armageddon with Bruce Willis. But control is very critical. I mean, if you break it up into tiny little pieces, it's unlikely to help. But there is a website that NASA has that, you know, tracks potential objects that are going to collide with Earth. Now, the Jovian planets, particularly Jupiter, do affect or can redirect a comet or a cosmic object in our solar system. So Jupiter has directed some comets toward Earth, but has ejected many more into the Oort clouds. We can thank Jupiter for that, at least so far. So then it kind of begs the question, was Jupiter necessary for life on Earth? Because, you know, Jupiter has this large gravitational pull. It's a very massive object in the solar system. And, it, you know, because of its gravitational pull, it can redirect objects. So impacts can extinguish life, but, you know, Jupiter has been able to deflect some away from us. So it's just kind of a happen chance as to, you know, how life evolved on Earth and just all the circumstances that had to come with it. So it's kind of cool. Okay, so that does it for part 2. Yeah, let me know if you have any questions. I think you guys have review questions that are due, and best of luck.